Hello friends, welcome back to today's class. So in the previous class we have seen your memory hierarchy system, this slide. I hope you remember. I hope you have watched the previous video. We have discussed in detail what is memory hierarchy, how to deal with this memory hierarchy, which is the memory which is present just very close to processor. All those things have been clearly seen in the previous class. And we have also seen which is fast, which is having lesser cost, which is having higher cost, and which is having lesser size. All these three aspects have been discussed, as well as we have also discussed the trade-offs between them. Like if one of them is giving us good speed, then it will be having less size. Or if one of them is giving good size, that is large size, then its speed will be less. So all these things have been already covered in the previous class. Okay. So to move ahead from the previous class, today we will try to touch upon the next important aspect, which is regarding your memory system. So in that we will primarily discuss about your cache memory. So cache memory, where is cache memory? Even that we have seen in the previous class. I hope so you can just answer this question. Where is cache memory? Just pause the video and you can try to answer it. So the answer is the cache memory is one which is very near to your processor, just near your registers. That is your cache memory, that is primary cache, and the second one is secondary cache. We call them as L1 memory and L2 memory. Okay, so what actually is this cache memory? The main aspect of this cache memory is nothing but speed. That is, it is very speed. Now why it was reduced, why it was designed? It was designed in order to save the time, so that whenever you want to fetch any data from the memory, instead of going to the your secondary memory or to the hard disk, instead of going there, you can just fetch it from the cache memory, which is very near to your processor. Okay, so going ahead in your cache memory, so cache memory, as you can see in this slide, it was designed so that you can save some time. Okay, so another very important thing is why the saving of time is required, so that you can get some good performance. You can see here. So if I want to achieve good performance, then we need to what now? We need to save the time in fetching the data and again giving back the information. That is done when it is speed. So that has been achieved with the help of your cache memory. Okay, so this is the first point. Now next very important thing is how do we arrange this cache memory? So cache memory is something which should be made to be available very near to the processor. That is, it should be so near to the processor that it should not try to go to your hard disk. Okay, so basically we have two cache memories. There are two types of cache memories. One is called as primary cache and another one is called as secondary cache. So this primary cache is available near your processor chip itself. Therefore, we call it as L1 cache, as you have seen in the previous slide. And the secondary cache is between the processor and the main memory. That's why we call it as L2 cache. So you can observe here in this slide, the primary cache, which is L1 cache, is available just here. You can see the primary cache just very near to your processor. That's why we call it as level 1 cache. Next, your level 2 cache. Here, the level 2 cache which is available here, it is in between your primary cache and the main memory. So this is your nothing but your level 2 cache which lies between your primary and the secondary. Okay, so if you see your today's system, that is whatever the systems we are getting right now, we have another cache which is called as level 3 cache. Even that is available in today's systems. That is we are also designing a level 3 cache. Okay, now how do you decide the effectiveness of this cache? That is, how effective is my cache? That is decided with the help of a property called as locality of reference. So using this locality of reference, we will be able to decide, we will be able to analyze what time the execution would take place. That is, if I want to get the instructions executed repeatedly, one after the other. Like say for example, you are running a loop. So if you are running a loop, the requirement is what now? You should execute the instruction again and again, n number of times. In such a case, you require the instructions to be fetched repeatedly. Then if that repeated execution is becoming fast, it is the only reason behind it is your cache memory. Okay, so in that case, what you need to do, you need to keep your instructions in a local area. So what do you mean by local area now? The local area is nothing but your near your processor, so that the execution becomes very speed. Okay, so what see here, please observe this slide very carefully. You can just see here the instructions may be in loop, nested loop, or in your few procedures, you can see it. Okay, so if I want to execute such instructions which are in loop, nested loop, or in the procedures. What are procedures, friends? Procedures are nothing but your what? Your functions. Sometimes we call them procedures, sometimes we call them your functions. So if the instructions can be repeatedly, or if the instructions are repeatedly executed, and if I want them to be accessed frequently, then you require this concept called as locality of reference. That is, the meaning is nothing but many instructions will be placed in a local area of the program which would be executed repeatedly. That means the instructions which we are executing repeatedly will be kept in the local area, and the program which is less frequently accessed, that will be kept in some other area. This whole concept is called as locality of reference. Okay, so I hope you understood the meaning of locality of reference. If the loop instructions, if I have some loop instructions, and if I want them to be accessed repeatedly, then I will be keeping them in a local area. Then we call it as locality of reference. Now, how this can be done? How locality of reference can be done? Locality of reference can be done by two methods. One is temporal method and another one is spatial method. Okay, so we'll just have a look at these methods now. Okay, so as we are speaking of locality of reference, there are two types in this. One is temporal locality and another one is spatial locality. Okay, so using these two concepts, we will be trying to get your locality of reference. So what do you mean by temporal locality now? The meaning of temporal is nothing but which is recently referenced memory. Like say for example, which is referenced again and again, temporary. Okay, so which is, you can say, which has to be executed again and again, and the execution should be very soon. That is nothing but your temporal reference. Okay, next comes is your spatial reference. So when we speak of spatial reference, it means that the memory locations which should be close to the reference memory locations. That is, say for example, I am taking the data at 2000. Then in spatial locality, you will be also taking the data which is at 2001 and 1999. That is, you will be taking the memory locations which are close to the referenced memory. What is my referenced memory right now? 2000. What are the memory locations which are close to my referenced memory? 2001 and 1999. Right? So that if I want such access, then we take it as spatial reference. Temporal means what? Only the referenced memory, only 2000. Spatial means what? We will be taking 2001 as well as 1999 as well as 2000. I hope this is clear. So that means what we do, you can just observe here in the slide, instructions with addresses close to recently instructions are likely to be executed soon. That means the instructions which are very close to the recent instructions, even that can be executed, right? But in temporal, what is happening? The instruction is likely to be executed very soon. That means only the recent executed instruction would be executed very soon. But what is happening here? So here only recent instruction, here close to recently executed instruction. So I hope you have got the difference between temporal and spatial. Okay friends. So this is regarding your temporal and spatial. Now, so in this figure, you can just have a look at how your cache memories are connected. You can just observe here. First you have a processor then you have a cache which is usually a small size, then you have a memory which is usually a large size. But coming to speed friends, which is speed? This cache, even though its size is less, right? Its size is less, but speed is high. But here size is more, the size is more, right? The size is more, but what about speed? Speed is less. So this is the major difference between your main memory and the cache memory. Okay, now one very important thing here is, whenever a read request has been sent by the processor, what would happen? A read request is sent from the processor, then a content, then you should get a data. That is nothing but you should get the data. From where? From the memory. Which memory? That means from the main memory, first it is copied into a cache memory, right? So that means you can just have a rough idea here. What will happen first? A read operation has been sent. When a read operation has been sent, say it will go to a cache. Then inside cache, let us now assume that there is nothing. Then what cache will do? It will go to main memory, fetch the data, and it will come back to cache memory. That means whatever the data is there in the main memory, that will be coming and getting stored in your cache memory. Okay, so this is very important, friends. Then later what will happen? Whatever the program references have been done in the locations, then those contents can be read directly from the cache instead of going to the main memory. That means you already brought the data to your cache. So instead of every time going to main memory, what you will do? You will just fetch the data from the cache and you will start to read. Okay, but what is one disadvantage here, friends? The cache memory size is very less. Therefore, you cannot store all the data inside your cache memory. That means you need to go to main memory. So this mapping, whatever is happening between your main memory and cache memory, whatever the mapping which happens between the main memory and cache memory, that is taking the data from the main memory, then again taking the data from the main memory into the cache. This whole process, what is happening, this is called as mapping function, or this is defined by a function called as mapping function. So you can just observe in the slide here, at any given time only some blocks in the memory are held in the cache. Why? Because of the less size. Now which block is in the main memory or in the cache is determined by the mapping function. So using a mapping function, what you will do, will determine whether the data is present or the data is absent. Okay, so this is one thing. Now what is another thing which may arise now? As we are speaking of size of the cache, it might so happen that the cache memory might get filled. It would get completely filled up. It's like a bucket. You are putting the water from a tank into the bucket. Then it might so happen that the bucket will get filled, but there is lot of water in your tank. That means what you need to do now? The bucket has to be again emptied. So this process wherein your cache becomes full, then some data has to be transferred from the main memory so that your cache must be replaced. This is called as replacement algorithm. Okay, so we'll be also trying to study some rules and factors which will decide how this replacement algorithm will work. Now it might also happen that some slots would be not available in your cache to place a block which you have brought from the main memory. Then you need to implement a replacement policy. That is, you need to decide which is of higher priority, which data is of higher priority and which data is of lower priority. The data which is of lower priority has to be removed and the data which is of higher priority has to be kept. That policy has to be determined, which is called as replacement policy. Okay, so even this we will be trying to look after in this whole chapter. Next, so next very important thing, friends, here we have something called as cache hit. Okay, this comes under cache operations, which I will cover in your next video. Thank you for watching. Please try to keep a continuity in your video sessions so that you will understand the next concept, because if you had observed, when I started today's class, I gave you a short glimpse of your memory hierarchy, right? So why memory hierarchy was required? Because we have to understand where is cache placed, whether it is placed near processor, whether it is placed near your magnetic disk, that has to be decided whether it's a level 1, whether it's a level 2, level 3. How will understand that? When you see the previous video wherein we are discussed regarding your memory hierarchy. So my request is you have a continuity in your video watching, so that you will understand what happens next. Okay, so if in the next video I will be explaining this cache hit. So if you want to understand this cache hit, it's very important where this cache hit occurs. Directly if you see cache hit, you will understand nothing. You should try to understand it comes under cache memory, it has some replacement policies, it has some locality of references, all these things. Okay, so thank you for watching. We'll again meet in the next class.